Yesterday we did this funny thing using the difference quotient at a single point. Doesn't seem to make sense because you get like 2 minus 2 over 1 minus 1 or something, right? You get this 0 over 0 thing that happens, and you can't do that, obviously. So we introduced this new notation where we go the limit. I'll actually do it. The limit as x approaches 1 or whatever value you happen to be doing, and that allows us to say, well, we're not going to do it like if I plugged in 1, I'd get 0 over 0, so I can't. So instead of doing that, I'm just going to pretend like I'm getting really close to 1, but like I'm approaching 1, I'm getting really close to it, but it's not actually at 1. And that bypasses the problem of having 0 over 0. And we saw the estimation where you can do this estimation. You can see what the number actually approaches, and that's one technique, but it's not very efficient. And then we saw this other one where we do some work, and the 0 over 0 factors out. But it seems strange. Remember, it seems like this thing where we're like, hey, math, look over there, and then, oh, everything's fine. And like it feels wrong, I think. Feels like, how can you divide out the zeros and then use what's left? Like there's something about it that seems wrong, but I'm going to try to just kind of quickly talk about what's actually happening and why it makes perfect sense. Now, if you don't follow every little bit of this, you don't quite see it, it's fine, because you just need to know, you do need to know how to do the algebra, but I'm going to show you what's actually happening, and it's based on understanding that we already have, so it's fairly straightforward. Adam, what's up? You don't have to copy this down. Okay, so if I'm taking the limit of f at x at 1, when I find, I've already done all the work for this again, so I'm going to go through it quickly. I believe this works out to -6. I hope it does. When I plug 1 in. And so I get the limit of f at x minus f at 1, right? So that ends up being x cubed plus x squared minus 4x minus 4 minus -6, so plus 6 over x minus 1, right? So this is what it works out to. And then the limit as x approaches 1, this is x cubed plus, and this is a good little trick that's coming up here, plus 2 over x minus 1. So I think I mentioned this yesterday. If you got a polynomial like this, a cubic polynomial, you'd have to factor it. How do you factor this? Because the one we saw the other day was a difference of cubes. How would I factor this? Synthetic division. But you'd have to use factor theorem. You have to go hunting for a factor. And that might take some time. So what would you do? Oh, you might be able to factor by grouping. The top one does. I don't know that this one would. I don't think it would. Yeah, you might be able to. There's an even better way though. Yeah, x minus 1 is going to be a factor, right? Like it kind of has to. That's the whole point of this. So you got to make sure that it works, that you didn't make a mistake. Remember I said sometimes people make a mistake just doing that, unfortunately. But x minus 1 is supposed to be a factor. So we actually don't have to go hunting, and we can just do synthetic division or whatever. So I should have x minus 1, and then the result, what's left is x squared minus 2x minus 2 over x minus 1. Here's what's tricky is when we do this and we go to the next line, it seems like this shouldn't work, or why would this work? It seems like if you couldn't plug 1 in before and now you're allowed to, I don't know, there's something about that seems weird. But somebody tell me, this is what I want to talk about, okay? If I think of this as a function, I'm going to use a different letter because we already had x. If g at x is this, x cubed plus x squared minus 4x plus 2. Remember, and this is great because it's good review for the final exam coming up. In Unit 5, we might have sketched something like this. Do you think this would have been something that we would sketch, right? So thank you. What would we know about this function? This function has a hole in it. It doesn't exist. We want it to. But how would I graph that? Remember what these graphs look like? They've got like vertical asymptotes, and sometimes like this one wouldn't look like that. But just to give you a quick reminder, they would have maybe like this one wouldn't, but another one would have a couple of vertical asymptotes, right? And then it probably has a horizontal. It would have a horizontal asymptote too. Let's say like this, and it might go like this and like this and like this or something like that, right? Like there's these graphs that look like this. So. But this one wouldn't look like that because it doesn't have a vertical asymptote. It has a hole. What would it look like? It would look like what's left after I take the hole out. And if I complete the square, I could actually sketch it. Okay, so this has a shift to the right 1 and down 3, and it's a parabola. Whoops. Okay, that's it. And this is what that function would look like, but it would have a hole at the spot that we want. But we want to know what the value would be at that spot, and we can use this function, which is what's left, to check. So we're taking that hole, and we're kind of plugging it for a moment, checking what's happening, and then we don't have to worry about the 0 over 0 anymore. So this is what we're actually doing. Okay? And we know that these things have the slope of the tangent. It's just the formula that we were using, which is what this function is. This function is based on the formula for finding that slope. And this is equal to that formula everywhere and will tell us what the slope of the tangent is. I mean, that's the way that it works. Okay? So it's interesting that there's this application of our understanding of the relationship between sort of a hole in a function and how we graph it that all of a sudden allows us to find these instantaneous rates of change, the slope of the tangent. It's kind of interesting. So again, if you didn't fully, like if you're like, okay, I understand what you're saying about holes, but not fully getting, still seems a bit fishy. Don't worry too much about it, because but some people might find it interesting that that's what is actually happening. So there's nothing fishy going on here. Any questions? I've lost my note here. I think I've got a problem with my note too. As I said, there's 3 types. This is a polynomial. That's one of the 3 types. We saw 2 of them yesterday. In fact, we're only doing one of the new ones today. So this is a polynomial type. Okay, and we're going to start with the formula. Slope of the tangent equals the limit as x approaches a of f at x minus f at a over x minus a. And we're finding it at x equals 3, so it's a limit as x approaches 3. And that reminds me that we need f at 3. And I get -9 plus 6 plus 3, so 0. Which makes the math a little bit easier. So f at x is the actual expression, f at x, x squared plus 2x plus 3 minus 0 over x minus 3. And go ahead and take off. You probably know how to do this. All 3 types of questions have slightly different techniques that we use to put them in the right form to get the factor out that we need. The polynomial is just factoring. And as we said before, we kind of know that one of them has to be x minus 3. So if you factored this wrong, or if you had made a mistake and you factor it and one of them isn't x minus 3, you've done something wrong. Okay? And this is just a simple trinomial, so it's not necessarily helpful to know that. But yeah, it turns out x minus 3 is one and x plus 1, I believe, is the other. Oops. Oh, and that, so now, sorry, I don't need that anymore because now I can just sub in. Equals negative 3 plus 1, which is negative 4. That one's okay? Already got it? We've seen this type as well, although I'm going to show you, it's marginally different, slightly different, but another way that you can do these is really, I mean, it's basically the same thing. But so get the first sort of 3 steps done, and then if you want to stop and wait, you can try the whole thing if you want, and then just watch. Sometimes we say slope of the tangent. Sometimes we say I rock instantaneous rate of change equals. So yesterday we did a couple of examples of rational functions like this one, and we got a common denominator in the numerator. So you can do it that way, or it's basically the same thing. You still would look for a common denominator, but instead you multiply the whole thing. So my common denominator on top would be x plus 3. So I multiply the top by x plus 3 and the bottom by x plus 3. And what this is actually going to do, but it really, like, if you look at it, it's doing the same thing, but you would be clearing the denominators on top, but we're multiplying by 1, obviously, in a convenient way. And I always find some people like doing it one way and some people like doing it the other way. And so you just got to pick whichever one you like best. What ends up happening, I'm going to write out an extra step here, is you get x minus 1 over x plus 3 times x plus 3. And then you also get negative 2, make sure you do this one, right, times x plus 3. And then on the bottom, you get x plus 7 also times x plus 3. So I have had to distribute the x plus 3 to both parts on top. And it gets you to this line just like the other way would have. And I got a quarter. So polynomial type, rational type. Next example is the third type. You need to learn the technique for how to do that. It's different. And then those are the only types. Tomorrow, we do, the question is worded differently. It's the same math, and it only ever deals with these three types of functions. But the question is worded in a different way, and that does, some people do find it confusing. So tomorrow is an important day for a separate reason. Everybody okay with this one? All right, let's see what the third type is. Square root. So the first little bit of setup is all the same, so you can get started on that. So this is the step that you should be able to get to. We're kind of set up, getting ready to start the algebra. Again, polynomial, you'd be factoring. With the rational, you'd be doing a common denominator. What the heck are you going to do with this one? How in the world? Like, this is a funny one because it doesn't look like there's anything. Like, it kind of looks like, I don't know, how is that going to work out to 8? Does anybody have any thoughts? Square the top and the bottom, that's a good idea. That's one that comes to a lot of people, but I don't think it's going to work because if I squared the top, I would have to like square the whole thing, right? It'd be the whole thing squared. And it's not going to have the effect that we would want it to. And then if I ended up getting x minus 8, it would cancel with only one of the x minus 8s on bottom, and I'd still be dividing by 0 because I'd have x minus 8 all squared. So unfortunately, I think that's not going to work. Although the idea behind it is what we want to do. We just have to do it in a bit of a different way. We can't just square. Multiply and divide by x minus 4. multiply by x minus 4. So it's going to get rid of this, but then I'd have to multiply that by x minus 4 as well, and I'd still have it, and I'd still be stuck with it. So it's not going to help. Again, very close. We're on the right track. We're not quite there. This is a hard one to come up with. No, because I'd have to multiply the 2 by that as well. So I'd still have it. Adam? No, good thought, but nope, that's not going to work. The conjugate! X minus 4 plus 2. Exactly. Very good. It's fantastic. But we have to do it. So you remember doing complex conjugates? I believe you would have done complex conjugates in grade 11 when you do imaginary numbers. And that is exactly what we do. There's all different kinds of conjugates, and it just means I multiply by the same sort of binomial thing on top here, but change the sign. And that's going to do what all of you were trying to do by squaring. Like this is what actually accomplishes that. Okay? Fantastic. I'm going to write now the whole point of the conjugate is we know what it does. So you jump straight to that. But I'm going to show you once, remind you what is actually happening. You know, it's like the difference of squares thing, right? So I get x minus 4 times x minus 4. And then I get x minus 4 times 2. So plus 2 root x minus 4. And then negative 2 times x minus 4. So minus 2 root x minus 4. And then negative 2 times positive 2, so minus 4. And then on the bottom, you got to make sure you write this correctly. Some people get lazy and they won't write it correctly, but you'll still get the right answer, but you'll lose half a mark or a mark on form. And then now we can see this is what conjugate does, is these two add to 0. And when I square, the square root of x minus 4 all squared is x minus 4. And then minus 4. And what are the odds of that? X minus 8. Is that a fluke? No, it'll happen every single time. If it didn't happen, you've made a mistake. You've punched something in wrong somewhere. Okay, it's this one in particular is funny because like you're not even like all you did was multiply by the conjugate and it just worked out to be x minus 8. It just happened that way. But it will happen every time. So if for some reason you're working and it didn't, then go find your mistake because you probably calculated f at x wrong or something like that.
Can we answer? Or
answer could be anything.
Oh yeah.
Because it's the slope of a tangent at that point, right? Is that what you're saying? Is that what you mean?
No, I was just wondering if we could use like if the number under the radical.
Well, so 8 minus 4 is 4, square root of 4 is 2, so this is 2 plus 2, so this is 1 over 4 again, just like the last question. That's strange. You're asking, would you ever get square root of a negative there?
Oh wait, that's just like the graph. Okay, never mind.
For our questions, you wouldn't. Is it possible to be doing math where the slope was complex, like had an imaginary part? I think sure. That's like it's possible that in a different question that's set up differently, that you could end up with a negative under the square root sign. That would just be working with imaginary numbers, right? But definitely won't happen for us. None of our questions would ever work out that way. Any questions? So there's your third type. That's how you do it. You multiply by the conjugate. You just got to know every type. The one's factoring, the one's common denominator, the other one is conjugate.